Hello everyone. Welcome to the class of aircraft structure. I am Zhang Qiyuan. In today's class, let's step into the world of aircraft together and get to know and understand its basic structure. This is like understanding a person's skeleton and muscles. It is the foundation for understanding how an airplane flies and how it operates safely. Clear objectives. In the time to come, we will focus on two core contents. 1. The composition of an aircraft fuselage. What are the main components that make up an aircraft? 2. Aircraft payload. What are the key forces that an aircraft experiences while flying and on the ground? What impact do they have? With these 2 points in mind, you can have a clear understanding of the structure of the aircraft. Entering part 1, getting to know the body of the aircraft. Well, let's first break down the body of the aircraft, the composition of the aircraft fuselage. 5 core components. Imagine an aircraft and we can clearly divide it into 5 main structural components. 1. Fuselage. This is the main body of the aircraft accommodating passengers, cargo, and major systems equivalent to the trunk. 2. Wings. These are the key components that generate lift and make the plane fly, and they are its wings. 3. Stabilizers, more called tail wings, which consist of horizontal and vertical sections, are responsible for keeping the aircraft stable like a tail. 4. Flight control surfaces, more than a variety of movable wing surfaces distributed along the edges of the wings and tail, which are the pilot's steering wheel and throttle and brake for precise control of the aircraft attitude. 5. Landing gear is the device that supports the aircraft in taxiing, taking off, and landing on the ground is the legs and wheels of the aircraft. A detailed explanation of stabilizers, the foundation of stability. Let's focus on stabilizers. It mainly consists of 2 parts. 1. Horizontal stabilizers provides pitch stability, prevents unstable nodding and raising of the aircraft. 2. Vertical stabilizers provides directional stability, prevents instability when the aircraft swings left and right. Simply put, the core function of a stabilizers is to keep the aircraft flying steadily. Without them, it's hard for the plane to maintain a straight and smooth posture. Flight control surfaces. The art of control now. Look at the moving parts of the wings and stabilizers. Flight control surfaces, they are the direct means by which the pilot controls the aircraft and are very important. What are the main ones? 1. Ailerons. Located outside the trailing edge of the wing, control roll tilt left or right. 2. Elevator. Elevators, and these located at the rear edge of the horizontal stabilizer, it controls pitch, raising and lowering the head. 3. Rudder. At the trailing edge of the vertical stabilizer, controlling your turning left or right. 4. Lift. Boosting devices, including leading edge flaps, leading edge slats, and trailing edge flaps, mainly extend during takeoff and landing to increase lift and reduce speed. Spoilers, and these on the upper surface of the wing, they destroy lift and are used to decelerate, assist in turning, or reduce lift, braking after landing. These control surfaces work together to enable the pilot to precisely control the aircraft to perform various maneuvers. Steering part 2. The pressure the aircraft bears. Now that we understand the body structure of the aircraft, let's take a look at the pressure it bears. And this, the aircraft load. Simply put, it's the various external forces that an aircraft is subjected to while in flight and on the ground. Main load types. What are the main loads acting on an aircraft? 1. Gravity. At the attraction of the Earth, always downward. 2. Lift. The key force produced by the wing to overcome gravity upward. 3. Drags. The air force that hinders an aircraft from moving forward, backward. 4. Engine thrust. 2. The forward thrust produced by the engine to overcome drags. At support point U, there is no horizontal force, only a downward reaction, which is the reaction force exerted by the ground on the landing gear during landing or when the ground jolts upward. Of these loads, lift, especially during maneuvering, flight, and ground impact force, especially during landing, have the greatest impact on the aircraft structure and are what we need to pay special attention to. Balanced flight level flight state. When the aircraft is in a state of equilibrium while flying at a constant speed in a straight line, at this point, the force acting on the aircraft reaches equilibrium. Lift equals gravity. The plane neither ascends nor descends. Thrust equals drag. The aircraft neither accelerates nor decelerates. This is the most fundamental and effortless state in flight. P10, challenging payload, vertical plane maneuvers like somersaults. If the aircraft is doing a curvilinear flight in the vertical plane, such as somersaults, its trajectory is approximately a circle. At this point, 1. Centripetal force is needed to maintain circular motion. 2. This centripetal force is mainly provided by lift. 3. But gravity is also at work, so the actual equilibrium is lift. The component of gravity in the centrifugal direction equals centripetal force. That means the plane needs to generate a much greater lift than the gravitational force to do that. Challenging loads, horizontal plane maneuvers such as turns, when the aircraft is making curved flights in a horizontal plane, such as a smooth turn 1. Centripetal force is also required to change the direction of flight. 2. At this point, the lift, L, of the aircraft will tilt 3. The horizontal component of lift provides the centripetal force needed for a turn. 4. The vertical component of lift must be equal to gravity, G, in order to keep the aircraft's altitude constant. Attention everyone, in order to provide sufficient horizontal component as centripetal force, the total lift must be greater than the aircraft's gravity. This will result in a higher load. Quantifying loads. Introducing the concept of overload to measure more scientifically the severity of the load on an aircraft, particularly its structure, we introduce a very important concept: aircraft overload load factor, usually denoted by the symbol N1. Definition: the ratio of the resultant force of all external forces, excluding gravity itself, acting on the aircraft in a particular direction, such as upward, forward, lateral to the aircraft's own weight, G, is the center of gravity overload in that direction. 2. The most critical y-axis overload in the vertical direction, Ni equals to lift L divided by aircraft weight, G. For instance, when the lift L is equal to the weight G during level flight, then My equals to 1. If the aircraft is maneuvering and the lift is twice the weight, then My equals to 2. We say the aircraft is under 2G overload. The meaning of overload is a critical indicator of safety. This overload value N is extremely important because it tells us directly 1. The extent to which the aircraft as a whole, including people and equipment inside, is subjected to external shocks. High overload means high risk of a passengers on board. It may cause black vision, fainting, or even injury. Think of the feeling of a roller coaster ride to aircraft structure. It may cause components to deform, crack, or even break. Why do fighter pilots wear special clothes and exercise so hard? Is to increase the tolerance of high overload. My could reach 9G. The ability to handle it for our aircraft maintenance personnel. The overload value Ny at landing is of the utmost importance. If this value is too large, 1. We must immediately and emphatically inspect the aircraft's fuselage structure, particularly the landing gear, wing joints, and the lower part of the fuselage. 2. This crucial overload value must be recorded in detail in the aircraft's history book as an important basis for subsequent maintenance. Fighting high overload, the secret of the anti-load suit. Just mentioned the anti-load suit for fighter pilots. Let's take a look at how it works. 1. The suit has airbags built into the thighs and abdomen. 2. When the aircraft is subjected to high overload modes, such as a large angle lift, the system uses compressed air drawn from the engine to rapidly inflate and pressurize the airbags. 3. The inflated airbags will press tightly against the pilot's lower limbs and abdominal blood vessels. 4. The main purpose of doing this is to slow the rapid flow of blood to the lower body, legs, abdomen under a huge overload, thereby helping to maintain the blood supply to the brain and prevent the pilot from black vision or fainting. This is a key piece of equipment for pilots to stay awake during high-G maneuvers. Focus on civil aviation maintenance landing overload. As future civil aviation maintenance engineers, you should pay special attention to the landing overload value and Y of civil aircraft. 1. How do you know this value? On modern aircraft, we can conveniently check the overload record for each landing through the MCDU, Multifunctional Control Display Unit, in the cockpit. 2. Automatic alert mechanism for safety. Many advanced aircraft models, such as the familiar Airbus A320, have a thoughtful feature. When the landing overload exceeds the safety threshold, the aircraft will automatically print out a load report. This is a clear reminder to pilots and maintenance personnel that a hard landing might have just occurred. Heavy landing case data speaks. Look, here is a real simulated heavy landing event payload report. 1. Heavy landing criteria. Airbus A320. Airbus has made it clear that a vertical overload and Y is greater than or equal to 2.6 G during landing is considered a heavy landing. 2. Case data shocking. The maximum overload recorded for this landing reached an astonishing 4.86 G, far more than twice the safety standard. This is definitely an extremely severe overweight landing. Consequences and handling of a heavy landing endured such a huge impact. 4.86 G. What will happen to the plane? 1. Damage is inevitable. The landing gear structure may be deformed or cracked, tires may burst, critical connections such as the root of the wing may be damaged. These are very typical consequences. 2. Procedures that must be carried out. In this situation, the plane must not continue flying. Emphasis: it must be grounded immediately for a comprehensive, in-depth inspection by a professional maintenance team and necessary repairs based on the results of the inspection. Only when it is confirmed that all structural damages have been repaired and the aircraft is fully restored to airworthiness can it be put back into service. Safety is always the top priority. Summary and conclusion. Alright everyone, today we have learned about the 5 major structural components of an aircraft and gained a deep understanding of the key loads acting on it, especially the concept of overload and its extreme importance in flight safety and maintenance support. I hope you can remember these basics, which are the foundation for understanding more complex aircraft systems. Thank you all for listening carefully. See you in the next class. Now comes the exercise session. Students can press the pause button to think and answer. Let's start now. Have all the students answered correctly?